Hello everyone. Hope you all are doing well. I'm Surbhi Jain, associated with TECOS as a senior quality assurance engineer. A very warm welcome to our session on performance test. We are going to talk about a couple of topics during this webinar, and we will also have a demo to showcase. Here is the agenda of the hour, which includes what is performance testing, why performance testing, some industry statistics on automation testing, advantages of performance test, types of performance testing, performance test tools, and we also have a demonstration of performance scenario. So the first topic is what is performance testing? Performance testing is a technique that determines how the stability, speed, scalability, and responsiveness of an application holds up under a given workload. Not only that, performance tests are also typically executed to examine robustness, reliability, and application size. It examines several indicators such as browser, page, and network response time. However, not limited to it. Let us now see what are the software problems we often encounter. Without performance test, software is likely to suffer from long load time, poor response time, poor scalability, and bottlenecking. If the software does not perform optimally, it will turn away customers who have become accustomed to speed. User will switch off if they find the software has excessive load time, which will eventually impact business. Now, why performance testing? Why should we do it? Performance testing is used to check how well an application can deal with user traffic. By putting a repeated scenario on an application or a site, it is likely to analyze the breaking points and assess projected behavior. Performance testing is performed to identify speed, scalability, and stability. Speed determines whether the application responds quickly. Scalability determines maximum user load the software application can handle. And stability determines if the application is stable under varying loads. We spoke on why we should consider performance testing. Now, let us run through some interesting numbers which have been compiled by a well known research organization. These numbers were gathered from multiple respondents from across the industry. This graph shows the current automation trends, and it is interesting to know that three-quarters of the respondents mentioned that automation is less than 50%. Shouldn't be surprising, I guess. We are all aware of the reality. The next survey was about what types of testing are you currently automating. Here we see that regression testing has the highest response and performance testing stand at just 29%. However, if you consider load testing as well, which is a part of performance testing category, then the numbers will be on a little higher side. The second survey data is about what types of automated testing are your QA and development teams primarily performing. Here we see that for unit testing, the focus is on development teams. However, when it comes to API and UI testing, QA is more active. In the demo session 2, we are going to use APIs to run performance test. Next question posed to the respondents was, beyond unit level testing, where do developers tend to contribute to an automated testing the most? The answer shouldn't be surprising, as most respondents mention it as API level, which makes sense as quality assurance folks mostly require a lot of information and inputs from developers before they can automate the test process for APIs. The pie chart data represents a very interesting question. Would you describe your test automation strategy as centralized or decentralized? Most of the respondents, that is more than 50%, mentioned that it is decentralized, and only 35% vote went to centralized approach. According to the link that I have shared in the slide, it says that centralized strategy is a better approach as it brings in more efficiency. As a matter of fact, I would like to highlight that I too have experienced the same. However, it depends on the leadership on what kind of approach is suitable for them. Both the options have pros and cons, so it is good to experiment and then decide. Now, let us look at some benefits and challenges. If you notice, faster testing cycles and efficiency scores highest with 63%, and a close second is a test coverage at 54%. When it comes to challenges, highest is finding staff with required skill set, which is where centralized team can be a beneficial option. The close second is an organization mindset towards test automation and aligns closely with the first slide, which clearly showed that only one-fourth respondents mentioned that more than 50% of test cases are automated. The other one is difficulty in creation of test data. Well, this is something we engineers will have to work and improve. At the end of the day, hard work is what gives you the desired results. So, how do you measure success? The top 6 performance indicators are listed here. If you see, then automated test coverage and number of builds passed or failed has got the highest response. The data is pretty much efficient to let us know if you're on the right track. This is the last data set that I would like to present. Does maturity matter? Benefits of an early stage versus advanced stage adoption. We can clearly see that advanced stage adoption provides us with better results in the long run. If you automate a very small portion of the test case, then it will not provide the right ROI. However, with more than 50% automation, we can see a lot of benefits and the ROI will be worth it. Hopefully, this data will also be helpful for our attendees to review their stand on test automation and to decide the future course of action. We saw some stats from previous slides. However, we will now continue with performance test automation as a topic for the day. We will now see at the different advantages that we garner from performance testing. The first one is validate fundamental features of software. Having a software foundation is a key principle of generating software success. Measuring performance of a basic software function allows business leaders to make important decisions. To measure the speed, accuracy, and stability. This allows you to monitor the crucial components of software under duress and gives you information on how the software can handle scalability. To keep users happy. This is quite an important point, isn't it? How do we know that? Since the load time can be tested before release, the software can be monitored so that the load time is within seconds, thus keeping the users happy. Improves optimization. Performance testing helps to know how end users are responding to software. Any known critical issues can be pointed to the customers. To identify discrepancies and resolve issues. Performance testing provides buffer for developers before release. Any issue can get magnified hence. Now, let us look at the different types of performance testing. We have load testing, endurance testing, volume testing, scalability testing, spike, and stress testing. Load testing. This is a practice of modeling the expected usage of a software program by simulating multiple users assessing the program concurrently. Endurance testing. This is about how long an application can handle expected usage of a software program by simulating multiple users accessing the program concurrently. Volume testing. As the name says, this is where the application is checked under various data volumes. Scalability testing. This tests how the system is going to perform during a sudden spike or a fall of user request loads. Spike testing. This is a type of performance testing that measures an application's ability to respond to a sudden change in the volume of data. Stress testing. This is the non-functional test technique to overload the application to ensure that it can sustain stress. Here we have some scenarios which we can perform to check performance testing. So the first one, as we see, is verify the response time is not more than 4 seconds when 1,000 users access the website simultaneously. Let's pick up another one, which says we can check the maximum number of users that the application can handle before it crashes. So these were few examples of the scenarios. Performance test tools. There are various performance test tools available in the market. Some of the most common testing tools include Apache JMeter, NeoLoad, LoadView, LoadRunner, and so on. The choice of performance testing tool will depend on what suits your requirement. We will consider Apache JMeter as a performance testing tool for a demonstration. Apache JMeter is a pure Java-based open source software which is designed to load functional behavior and measure performance of web applications. It can be used to simulate a heavy load on a server, group of servers, network, or an object to test its strength or to analyze overall performance under different load types. Let us start with a demo on performance test scenario using JMeter. We will use Apache JMeter version 5.4. We have used an internal application for the demo. We will see how to create a user, verify if the user is created, update the user data, and assign rights to the user. We also have an HR module wherein we have created vacancy type and a vacancy. There is an update and delete operation done on the vacancy as well. We've created a video for the demonstration for the better time management. Let us start with our demo. To begin with, let us name the test plan as Decor's sketch test. We will then add a thread group to the test plan. And to the thread group, let us add a logic controller, that is simple controller. We will name this as a user module. Let's save our project. It gets saved as GMX and we have named it as Decor Sketch Test. To the user module, now we will add an HTTP request, which would be to create a user. We can also add additional comments, which will help us to understand what each request does. Now to the test plan, let us add few user-defined variables, which are global variables. These variables will remain consistent throughout the test script. So we would add host and protocol values here. So we use an HTTPS protocol. Okay, we save them. Let's just zoom in for a clear view. Now, to create a user request, we would add protocol and host as defined in the global variables. And then we would select what kind of a request this would be. So create a user is a post request. So we select post and we give its respective endpoint. Before that, let us add the login ID and global variables. So this is the login ID of the logged in user, which would be used in the API endpoints. Now we would add few more global variables which we need to make the request generic. Now let us add another config element which would be CSV dataset config. So we create a CSV file with all the necessary attributes, and we would browse and we would select this file. In create a user body data, we would add the body data which would include the employee name, employee's location, employee's joining date, gender, and its designation. These values would be picked up from the CSV file we created some time back. Let us now add a listener, that is view results tree. Before we execute, we need to add HTTP header manager, which would define the content type considered in the HTTP request. So we have considered JSON body. So our content type would be application JSON. Let us execute. As we see, demo user 01 has been created, and now we would verify the same on the application. So demo user 01 is created with all the data which was entered in the CSV file. Let's proceed further by adding another HTTP request, which would be to get the user data. So we have added protocol and host. This would be a GET request. Let's give the endpoint. We have disabled create a user for now, and let us just execute get user data. On execution of get user data, we would see the response data gives us the information of all the employees. So we will try to get the employee ID of the user which we have just created with the help of JSON path expression. This would be added as a post processor. So we have used JSON extractor as a post processor, and we would add the JSON path expression which we just created. Let's give a name of the variable as employee ID. The batch number would be 0 and the default value would be not found. We can also name the JSON extractor as get employee ID. Let's add another HTTP request to update the user data. So here we would try to update the employee name of the created user. This would be a post request. Let's give its endpoint. And the body data would now contain an updated employee name. So in the CSV file, we would have another attribute of updated employee name, which would be considered. Let's save and run the request. Before that, let us add another request to verify if the user data has been updated or not. In order to do that, we would add protocol and host. It would be a GET request, and we would add its API endpoint. On execution, we would see that the request have been passed, which means the username is updated. Let us verify with the help of JSON path expression. So we would add a JSON assertion to verify updated user data. So here we would verify if the employee name has been updated to the updated employee name value mentioned in CSV. Let's try to make the JSON path expressions generic. Now we would see that on execution, the name has been updated to updated demo user. And we also see that when a new user is created, it has only general user rights. So let us try to assign some rights to user. So we created another HTTP request for the same, and we have assigned rights. Let's verify if the rights have been assigned. As we see on edit, the user is assigned development group rights. Now let us verify if the rights have been assigned to the user or not. So for that we would add a HTTP request. It would be a GET request, and it would get all the employee data. Let us create a JSON assertion XPath from the response, and we would add the expression in JSON assertion, which would validate if the development group ID is active or not. On execution, we see that the request has been passed and its value is true. Let's enable all the requests and run the entire module. As we can see, demo user 01 is created, its name is updated, and development group ID is assigned. Let us verify the same on the UI. So we have updated demo user 02, and on edit we would see it has been assigned to development group. Now let us try to consider the recruitment module. For that we would add another simple controller and name it as recruitment module. To this, let us add an HTTP request to create a vacancy type. So we would be creating a vacancy type for India location on our website. This would be a post request. Let's give its respective endpoint. We have also considered a unique value that would be a random unique value which would be appended to the vacancy type name. The body data would contain the login ID and the vacancy type name, which would be added in the CSV data. So for now, let us give vacancy type 01 as the name and vacancy code as VT01. Let's disable user module for now and run the request. As we see, vacancy type 01001 has been created. We can verify the same on the UI. In vacancy IN, we have vacancy type 01001 created. Now let us add another HTTP request, which would be to verify if the vacancy tab has been created or not. So let's add a protocol and host. It would be a GET request. And from its response, we would add a JSON path expression to verify, to fetch the vacancy type ID. The same expression would be used in JSON assertion. And we would give the expected value as vacancy IN. Let's add another extractor to this request, which would help us to extract the vacancy type ID. So app picklist ID is the name of the variable, and let's add the expression and set default value as not found. Now let us add another sampler, that is another request to create a vacancy. This would be a post request. Let's add this endpoint, and the body data would include vacancy code and the vacancy type. Let's run this request and verify. As we can see, VT01. Let's verify the same on the UI. VT01 is created and it does not have any close date, or it's not marked as fulfilled. Now let's fetch its vacancy ID. So once a vacancy is created, it is assigned a unique ID. So let's fetch this. So this would be a GET request, which will give us all the information of vacancies. From the response, we would fetch the vacancy ID, which is against the respective vacancy code. So the vacancy code is VT01 and its ID is now fetched. So we would try to add a JSON extractor which would help us to fetch the vacancy ID from the GET request. The default value is not found. Let's add another request to update the vacancy. So we would like to mark the vacancy as fulfilled and we would like to assign a close date to it. So for that, we would create a post request, and in the body data, we would add a close date and mark fulfilled as yes. Let's execute and verify. On the UI, we would see that we have a close date and it has been fulfilled. Now we need to verify. Sorry, we would now delete the vacancy type which was created earlier. It would be a post request and the body data will contain the vacancy type ID. On execution, we would see that the vacancy type has been deleted. Let us execute the whole recruitment module. We see that all the requests have been passed successfully. As we can see, the vacancy type is created. (03001) and A vacancy is created and it is also marked as fulfilled. The vacancy is deleted as well. Now let us enable both the modules and run for 50 users with a ramp up period of 500 seconds. So this would mean 50 users would execute in 500 seconds. Let's, Let us add a summary report and an aggregate report, which would help us to view the results in a better way. We've also added a response assertion, which would verify that the response code matches 200, which would mean OK. So this is how our test data looks like. And now let us run the request. As we see, within 10 seconds, the first user has completed, and then it would wait for a while before it begins the next thread. As we see, the users are getting created. Also, the rights are assigned. Vacancy type is created. A vacancy is created, and we would update it as fulfilled, and then we would delete it. The vacancy name is to be unique, so if it was created earlier, it would throw an error. The summary report, it shows the number of samples, the average time taken for the request, the minimum time taken for the request, also the error rate. The aggregate report in addition shows 90% line, 95% line, and a 99% line. This ends the demo. I hope that the demo was insightful and has helped you to understand the importance of performance testing. Now, it's time for Q&A. We have received a few questions. Let's answer some of them. The first question asked is, how should you approach performance testing? What should be the starting point? Well, this would depend on which development lifecycle is considered, whether it's an agile or a waterfall model. In agile, we have an iterative development, hence it would be recommended to start as in when few functionalities are available. In the waterfall model, performance testing is typically conducted when an application is fully developed and functionally stable. The starting point or the prerequisites for performance test depends on if it's an API test or a UI test. For an API test, we would need all the info on the API endpoints from the developers. And for the UI, one can record and play the script. Let me try to answer another interesting question. What kind of performance testing can we do apart from API level testing? We can do UI performance testing, infrastructure level performance testing if the system is on the cloud. Let's pick another question. So, when can we expect to see some ROI on a performance test initiative? The return on investment will depend on few factors like size, complexity, size of the test engineering team, staff efficiency, and so on. A rough estimate would be around 1 to 3 quarters. Do get in touch for a detailed discussion on the same. The next question which we would pick would be, how can performance tests help us in preventing cyber attacks? Performance testing help us to test the website for DDoS scenarios and gain extensive insights to help us protect from such attacks. Websites, web applications, and third party services can be stress tested for granular clarity. We can also get performance reports that will help us to uncover hidden vulnerabilities and bottlenecks for improving website robustness against such attacks. The last question for today would be, how do you automate performance test for endurance testing? Endurance testing helps to determine if the system can sustain a continuous high load. So here we apply a heavy load to the system for an extended period of time and we observe the behavior. To perform an endurance test, which we can include logic controllers such as loop controller, while controller, or even if controllers. That's all for today. We have a couple of more questions and our moderators will get in touch with you for the answers. Let us know how we can help you in your test automation journey. Thank you for attending this session. It was a pleasure to conduct this webinar. Have a great day ahead. Goodbye.